Okay, so that said, it's an honor to have Iryna Gurevych with us. She's going to talk about natural language arguments. Iryna is a professor in the computer science and director of the Ubiquitous Knowledge Processing Lab at the Technical University of Darmstadt in Germany. Her main research interest is machine learning for large-scale language understanding, including text analysis for social sciences and humanities. She's one of the co-founders of the field of computational argumentation, which is the focus of today's talk, which has many applications, such as the identification of fake news and decision-making support. She has received numerous awards, including the highly competitive Lichtenberg Professorship Award from the Volkswagen Foundation and also a DFG Emmy Noether Young Researchers Excellence Career Award. She is the current president of the Special Interest Group on data, which is one of the most prominent and important scientific bodies, the most prominent special interest group in the ACL community. She was program co-chair of our most important conference of ACL 2 years ago. She was also general chair of the STAR-SEM, the joint conference in lexical and computational semantics last year. She's also ACL fellow, which is a great distinction, and she's also ACL's vice president-elect. Okay, so without further ado, Iryna, you can take the floor.
Thank you very much, Eneko. Let me share the screen. So can you see the slides okay?
Yeah, perfectly.
All right, great.
Yes, they're okay.
Thank you very much. Thanks a lot for the introduction and good afternoon. I'm really delighted to present this talk with you today. The talk deals with computational argumentation, which is a fast-growing field with many applications in discourse analysis, summarization, debate modeling, and law, among others. Some of you might be familiar with this image. In the image, you can see the demonstration of the IBM Debater, a system which has been developed in parallel to the work in computational argumentation in our lab in Darmstadt in the recent 5 years. First of all, let's discuss a bit why do people love to argue. One possibility to know people's opinions about that is to look up this question on Quora, and that question happens quite frequently. And here I have extracted some of the answers given by people which are prototypical of various answers given. So first, when people are engaged in debate, they are effectively joined together in a search of truth. Second, for thousands of years in many unrelated cultures and traditions, many serious thinkers have held that the best way to get closer to the truth, justice, insight, or reality through different types of argument. Third, it's a primary learning method in schools, and even modern science is a sort of one long multi-partner, multi-strand argument over time, which is, in my opinion, a very fascinating way of thinking about computational argumentation. And finally, arguing is an extremely effective way to gain knowledge, learn about another person, understand yourself, and just practice communicating. Also, it is exciting. So first, let us define argumentation and relate it to something that many of us are more familiar with: sentiment and opinion. Sentiment and opinion is about analyzing people's sentiments towards a topic. The computational argumentation is about convincing somebody of a specific viewpoint. Defining argumentation is very hard, and there exist many different definitions. So one of the widespread ones is the definition of argumentation as a verbal, social, and rational activity aimed at convincing a reasonable critique of the acceptability of a standpoint by putting forward a constellation of one or more propositions to justify this standpoint. In fact, the bridge in between opinion, mining, and sentiment and argumentation is an open fundamental research question yet. Next, let us look at some examples of arguments and their structure. A common definition of an argument is that this is a claim, like physical education should be mandatory in schools, so by reasons like more than 100,000 people died in 2011 due to lack of physical activity and obesity. And then there is a relation existing between these two pieces of text. In this case, this is a support relation, so the premise is supporting the claim. Of course, in real life, argumentation structures are much more complex. We have to deal not only with support relations, but also with attack relations, the so-called rebuttals. For example, for the claim, living and studying overseas is an irreplaceable experience. When it comes to learn standing on your own feet, we can have supporting premises like the one will learn living without depending on anybody else, or attacking premises like one who is living overseas will, of course, struggle with loneliness, living away from family and friends. And then we can have a chain of premises like this one. Those difficulties will turn into valuable experience in the following steps of life, which is attacking the preceding text snippet and which is changing the overall stance of two premises chained together to a support relation. So the main challenge of computational argumentation is to extract these kind of structures from natural language text. As I have already mentioned, computational argumentation has a vast number of applications. For example, decision making, when we are concerned with evaluating various options and want to understand their pros and cons. Persuasion, where, for example, a doctor is trying to convince a patient to change a particular pattern of behavior and is using arguments for that. Argumentation is the foundation of critical thinking and is the basis of any democratic society. So argumentation is already taught quite intensively in secondary education. And finally, as I've already mentioned in the Quora discussion, argumentation is fundamental to our main field of work. It is fundamental to science because constructing valid arguments leads to generation of new knowledge and to validation of existing knowledge. In our lab, there has been a long tradition of research on computational argumentation. As I have already mentioned, I was one of the founders of this area. Yeah?
Sorry, I interrupt. There is a little box in the top which hides the title of the slide. Maybe, yeah. Okay, thank you.
This one?
Yeah, that's better. Thanks.
All right. So in this slide, I would like to give an overview of our research in computational argumentation. As I've already mentioned, we have been working on this for about 5 to 7 years together with IBM and other colleagues. And we have worked both on the analysis of arguments within a discourse and on a more information retrieval oriented setting. In this setting, we have an input like a claim, a statement, or a topic, and we then retrieve relevant documents and extract argumentative statements from the documents. Those statements were subject to various kinds of research questions like stance detection, identifying arguments at different levels of granularity, or in multiple languages. And another quite huge topic is assessing the quality of arguments. Based on the argumentative statements and their classification, we have worked on extracting and clustering argument aspects, describing the core of the arguments. And finally, we have worked on argument generation and various applications of argument mining, like argument search, fact-checking, interactive evidence detection, or dialogue systems. In my talk today, I'm going to talk about two research pieces. So the first one is our quite early work on argument mining related to extracting arguments across different topics from heterogeneous sources. And the second research piece is our current work on aspect-controlled neural argument generation. So let me start with the first project, which is about the problem of argument identification. And in this slide, you can see a high-level structure of this problem. We have a collection of documents, and we have a controversial topic like autonomous cars or basic income. And the task of the system is to extract pro and con arguments from those documents, which in this case we consider at the level of sentences. So this is, in this particular piece of work, a sentence level classification task. So one of the challenges when starting to work on such a novel domain in natural language processing is how to create training data. And argument mining is a complex task, so humans are not a very good model for this. So it's very hard to annotate arguments in natural language text. So in this work, we have proposed an annotation scheme which should be applicable to our problem definition of argument search in heterogeneous web sources. And this scheme should be, on the one side, general enough for heterogeneous texts, and on the other side, simple enough for crowdsourcing in order to generate a large amount of training data in short time and with limited resources. So our solution defines the topic as a matter of controversy that can be expressed with keywords. And argument is a span of text with evidence supporting or opposing a given topic. So as I have mentioned before, in this particular work, we consider arguments at the sentence level. So we have three classes, sentence-wise, pro, con, and no argument. And a distinguishing feature of pro or con arguments is that they should contain some evidence related to the given topic. Now let's have a look how the scheme can be applied to real-life data. In this example, we have first the topic of nuclear energy, and the first sentence gives us a definition of the nuclear fission process, which we classify as no argument because there is no evidence presented in this sentence. The second sentence goes like, the amount of greenhouse gases have decreased by almost half because of the prevalence in the utilization of nuclear power. This sentence is classified as a pro argument because it includes a reason why nuclear energy is good. Now, the third example is about the topic of minimum wage, and it goes like, a study has found that minimum wage workers are more likely to report poor health and suffer from chronic diseases. Here, the sentence talks about negative consequences of minimum wage, so we classify it as a con argument. And now the last sentence is, we should abolish all federal wage standards and allow states and localities to set their own minimums. This example is presenting an opinion, but it does not giving any evidence for this opinion, and that's why, according to our model, this is not an argument. So please note that the last example sets our approach apart from the discourse agnostic stance detection task. Now, we conduct some experiments to verify this approach, and our data is extracted with the help of Google searches from the web. given 8 controversial topics like school uniforms or gun control, and it contains different text types like news, online discussions, blogs, social media, and so on. And in our annotation study, first 2 expert annotators independently annotate about 200 sentences for each topic, and we find sufficient agreement among these annotators, which shows that the annotation model is applicable to heterogeneous texts by expert annotators. But remember that we need a lot of data, so now the next step is to look how we can scale this up, and we conduct an initial study which employs 10 crowd workers to re-annotate the expert annotated data on Amazon Mechanical Turk. And then we merge the annotations of the crowd using the maze metric. And then we measure the agreement of crowd workers with the experts. And we find that with our annotation scheme, we can achieve high quality annotations using crowdsourcing, and the crowd workers achieve about the same level of statistical agreement with expert annotators as the expert annotators among each other. So we consider this to be a very good result, and then we apply this result to generate our final corpus, which contains 25,000 instances produced or annotated in less than 1 week at the cost of about $2,700. And with this corpus, we learn a classifier for argument mining across different topics. So in our experimental setup, we experiment with 2 scenarios. So the first is a 2-label task where each sentence is classified in 2 classes, argument or no argument relevant to the topic. And the second scenario is the 3-label task where we classify a sentence as no argument, pro argument, or con argument with regard to the topic. And we apply this cross-domain, that is, we train on 7 topics and test on our left-out 8th topic. In our early work, we employed transfer and multitask learning models based on LSTMs, and then later, in 2019, they were replaced by the BERT model with contextualized embedding that entered the market, which gave us a huge gain of 20% point in F1 macro, with a total of F1 measure amounting to 63 on a 3-label task, which is of course significantly harder than a 2-label task. In our analysis of results, we find that the system has still a significant gap of 18% to the human performance given by the upper bound of the human agreement. And we looked at different tasks in closer detail, and we found that, to be more exact, some colleagues that used our data set found in their recent work that the argument identification, that is the 2-label task, results in higher level of performance at F measure of 0.7, but the stance detection, which is important for our 3-label scenario, is at a significantly lower level of performance. So there exists a lot of room for improvement there. And the main reason is that we find that generalizing over topics for stance detection is significantly harder than for argument identification, because the lexical cues may signal positive or negative stance in different topics depending contextually on the topic. So this is a finding which already has been described in relation to sentiment analysis. For example, dark chocolate is good and dark thoughts is bad. So the stance depends on the local context, and the same happens with the problem of stance identification, which makes the task of argument mining across topics to be very hard. So now in the error analysis, as I've already mentioned, the model often confuses the stance. This is one common example of errors. For example, in there is reason even for people who oppose the use of marijuana to support its legalization. The model predicts con argument based on the lexical cue oppose, but in this case, the stance should be pro, because oppose is not used to oppose, but rather to strengthen the topic. And another observed mistake is the relevance of the predicted sentence. In particular, for some con arguments, the relation to the topic is not correctly modeled due to the lack of domain knowledge. So, for example, for the sentence, all the above gas, also known as the greenhouse gases, may cause global warming and climate change. The model predicts a negative stance, but the correct stance is the positive stance. So the argument talks about the negative effects of greenhouse gases. However, nuclear energy does not produce any greenhouse gases, and since the model cannot establish relation between these facts, the classification decision is wrong. To summarize this part of my talk, I would like to point out that we have proposed a novel annotation scheme for sentence-level arguments, which is reliably applicable to heterogeneous texts and simple enough for crowdsourcing. Using this model, we have constructed a large data set for argument classification that is widely used as a benchmark and contains 25 classified instances for 8 controversial topics. And in our conclusions, we find strong results in the cross-topic setup for the difficult task of combined argument and stance detection. However, stance detection turns out to be more difficult to solve than argument classification and remains a focus of future work. Also, we have shown that the model sometimes fails to capture the topic relevance due to missing world knowledge. Last year, there has been some follow-up research to this work. For example, people worked on language transfer of this model to other languages like Portuguese. Another research group worked on including more world knowledge inter text classification. And there has been work on explainability of classification decision, and also the work by IBM on retrospective labeling, which I find quite interesting. So the main idea in this work is that they use our data set, construct a classifier, and then produce a much larger noisy data set by applying that classifier on the data and re-annotate the automatically produced labels, resulting in a much larger data set, which is more noisy. But the model learned on that larger data set outperforms our results, though our data set is of higher quality but is significantly smaller than their data set. So now I'd like to move to the second part of my talk on aspect-controlled neural argument generation. And here I would like to give you some motivation for the task of argument generation in various contexts. For example, in politics, we need to prepare for a debate, and opponents, like for example journalists, may ask tough questions. So anticipating such questions and also anticipating counter arguments might be crucial for being successful in such situations. So our idea is to propose an assistive system which can help to construct counter arguments based on topics and their aspects. In our work, we build on top of the existing state-of-the-art in natural language generation, which has seen a lot of progress in recent years. So recent argument generation models are based on RNNs with sequence-to-sequence architectures, and later they were replaced by transformer-based language models showing impressive results. And also I'd like to point out that we are not the first to work on the task of neural argument generation in general. In particular, in prior work, there have already been attempts to apply neural models to argument generation. However, the main difference is that they did not apply any explicit control over the output, that is, over the generated arguments. And because of this, they suffered from the typical weaknesses of the natural language generation based on neural models in general. That is, the relation of input and generated content was not so clear and was underspecified, and also the generated text contained repetitions of the input. So our main idea for controlled neural argument generation is that we want to condition generation models on short control codes while training. And to enable controlled argument generation, we need to control at least over the topic, like nuclear energy, over the stance, that is for or against the topic, and importantly, over the argument aspect, for example, waste or health. For this task, we adapt the transformer-based CTRL architecture, which allows to condition it to certain control codes at training time. So in summary, the main properties of our approach are the following. We present a state-of-the-art transformer model that we apply to the sentence-level argument generation task. And the main distinguishing feature of our approach is the contextual control of generated arguments. To solve this task, we need to address two main challenges. The first challenge is how to identify argument aspects. For that, there previously has existed no readily applicable approach and also no data set. And the second challenge, we know that neural NLG is data hungry. So the question is how to generate massive amounts of training data, for example, or specifically the sentences labeled with topic, stance, and aspect. So such a data set does not exist. So let's have a look at the first problem of identifying argument aspects. So I'd like to elaborate on our definition of argument aspects with the following example, taken from the topic nuclear energy. We have the argument, running nuclear reactors is costly as it involves long-term disposal of radioactive waste. For our approach, we need argument aspects that we define as follows. They are not limited to any particular part of speech, different to prior work. That is, in one case, this is a noun phrase. In other case, it's an adjective or an adverb. Second, the argument aspects hold the core reason upon which the conclusion of the argument is built. So here the core reason of the conclusion is contained in the words costly and radioactive waste related to the nuclear reactors. And third, the aspects encode a certain stance towards the topic, and this topic does not have to be explicitly named within the sentence. So the aspects refer to this overall high-level topic of nuclear energy, though nuclear energy does not occur in the sentence as such. So for annotating argument aspects, we need to create a data set, and our approach is a two-staged one with experts and crowd workers. In the first stage, we have two expert annotators, and we define the task as a span level annotation task. They annotate 800 samples over 4 topics, resulting in the Krippendorff's alpha of 0.38, which is considered to be quite moderate and not very high. And because of this, we conclude that this annotation scheme as such cannot be applied in the crowdsourcing framework. Proposed solution instead is to build a recommender for crowd workers, building on top of this small-scale expert annotated data set similar to the work of IBM related to the argument classification, which I have mentioned while concluding the first part of my talk. So to do this, we proceed as follows. So we have a second stage where we train a BERT-based ranker for aspect recommendations trained on the expert gold labels. And what you can see in the table is that for in-topic, we have the recall of about 86% at 15. And cross-topic, we have a recall of 81% at 15, which means that about 8 aspects can be correctly found within, roughly speaking, 10 suggestions presented by the ranker. So the crowd workers can then go ahead and choose aspects from the list presented by the ranker, like shown here. And in addition, we also offer the possibility to label the aspects freely if there is no relevant aspect found in the list for the particular aspect they want to mark. So based on this, we collect a data set with about 5,000 high quality annotated instances with aspect labels, and the Krippendorf's alpha goes up to 0.76. That is very considerably as compared to the study without a two-staged approach, despite the fact that the first stage was conducted by experts only. So this ranking procedure helps to streamline the annotations a lot. And now, based on this data set, we train 2 BERT-based models, comparing to our ranker as the baseline and comparing to the majority baseline. And this way, we can train a sequence tagger with the F measure of 0.7 based on the BERT large model that can then label the aspects in our argumentative statements. So with this, I now move to the second part of this work, how to generate massive amounts of training data for natural language generation. And it means that we need sentences labeled with topic, stance, and aspects. To gather a large data set, it is obviously not feasible to rely on manually labeled data, and instead we focus on a semi-supervised approach. The approach works as follows. First, we retrieve up to 0.15 million documents for each of the 8 topics from the data set, which I have covered in the first part of my talk with 8 topics. And we use 2 different sources, Common Crawl and Reddit comments, while we treat these sources separately and train 2 separate generation models based on different sources for later comparison. We then apply sentence splitting on all documents retrieved from the sources and classify the sentences into no argument, pro argument, and con argument. As we are not interested in non-arguments for our task, we remove them from our data set. And next, we use our automatic aspect detection model to identify all aspects of the remaining pro and con arguments. Finally, we group all arguments with the same topic, stance, and aspect and concatenate them into our final training documents. To prevent documents being too small for training, we set a lower limit of 15 sentences per topic. And also we have an upper limit of 1,500 instances so that we do not overfit on large and overrepresented aspects, because the data can be very skewed depending on the topic. Next, the document texts are split by the maximum sample length, and each sample is prepended by the control code, that is the topic, stance, and aspect. And in the shown sample, this would be the nuclear energy as topic, pro as stance, and base load power as aspect. Contrary to the original CTRL, we allow for a control code of any length. And finally, at inference, we pass a control code to the model which generates an argument following that control code. For example, we pass the control code nuclear energy pro base load power, and the model generates an argument with this particular context, like nuclear power plants are necessary to guarantee base load power as, and so on. To analyze how well the trained Reddit and Common Crawl approaches perform, we generate about 8,000 arguments for each. And our ground truth consists of around 700 arguments for all 8 topics that we crawl from human-created websites such as procon.org and idebate.org. And for comparison, we use a strong retrieval-based upper bound. So this upper bound works by using information retrieval and returns all arguments from the training documents for each used control code. So this upper bound is strong because the arguments are of human origin, while our arguments are automatically generated, and the aspects are always to be found in the argument due to the model being based on the information retrieval. So in the table, you can see the results based on these approaches. Retrieval is our upper bound, and the CTRL is our own model. And we have 2 evaluation measures, and we have 2 different sources, Common Crawl and Reddit. And the main finding which can be inferred from these results is that our model turns out to be quite close to the upper bound, which we consider to be a very promising result. And this is also consistent across 2 different corpora and 2 evaluation measures that we apply in this evaluation. So please remember, in the beginning, I have said that our motivation is to generate counter arguments to help the speaker to prepare for a debate. What is a counter argument? Counter arguments describe the same aspect as the initial argument, but with a switched stance. So in this example, I'd like to present you some results that are generated with the help of our approach. So our input argument is school uniforms are expensive and affect the pupils' individuality. So the topic is school uniforms. The original stance is con. We turn the stance to pro, since we want to generate a counter argument. And then there is an aspect. In the first case, it's expensive. In the second, it's individuality. So the model outputs for the first aspect, the argument, the cost of the uniform is not that much more than a regular shirt and shorts. And for the second aspect of individuality, the model outputs the uniform is a symbol of human identity, which helps to foster an environment where students can feel comfortable about expressing their own individual style without being judged by others. So the approach, of course, is subject to various limitations, and this is our work in progress. So first of all, as already mentioned, transformers need a massive amount of training data. In our case, we have only 8 topics, and we need 1.6 million arguments to train our system. So using manually labeled data is not feasible. However, the automatically created training data contains errors from sentence splitting, incorrect stance or argument labels that become part of the training process. And in order to improve on that, we need higher quality pre-processing pipeline on the noisy web data to mitigate such negative effects. Also, the model needs at least 16 GB GPU memory to run. So it has high computational requirements, and it took us 5 days to train it, which is, of course, too long. So we need to work on making the approach more data efficient. And also the generation of a single argument at the time of inference takes up to 15 seconds, which needs to be quicker in our future work. So to summarize the second part of my talk, I would like to conclude that we have presented a novel method of aspect-controlled neural argument generation. And our method allows to generate high argument quality comparable to human-made arguments, as we have shown in the comparison to an information retrieval based upper bound. The main advantage of our approach is that we can condition the model on the aspect, topic, and stance. This way we can steer the process of argument generation at a fine-grained level. And we have also produced a new data set annotated for aspects, and those aspects, of course, could also be used in other ways, not only for the argument generation, but for example, also to label clusters of arguments. In our current work, we improve on the pre-processing performance, and we work on an argumentative scientific dialogue agent where we want to generate scientific arguments in a chatbot setting. And also we work on data efficiency to reduce training inference time requirements. Let me come to the conclusion of the overall talk. Argument mining research has diversified into a large number of subtasks where each subtask requires or deserves attention in its own right. So some examples of such problem domains are argument retrieval, stance detection, argument quality assessment and evidence verification, argument similarity and clustering, and argument generation, just to name a few of them. And there is a huge amount of future work possible, like working on better models, producing novel data sets for various tasks in argument mining, integrating this technology with interactive systems, and so on and so on. And just one example, which Aneko has also mentioned in the introduction, this type of research is very relevant to the current problem of the fake news detection and automated fact-checking. So there has been a finished PhD thesis in my lab, which presented some results for this problem. The main difference to the work which I have described today is that the claim is much more complex. So in this example, the claim is Israel caused flooding in Gaza by opening river dams. So we do not only have a short controversial topic, but we have a complex statement which can contain various kinds of semantic relations that need to be considered while relating the found evidence to the claim. And in general, the approach is similar in the architecture. When given such a claim, we need to retrieve relevant information from the web documents, and we need to classify the stance of the found information containing evidence related to the original claim. And then in the last step, and this is also different to the setup which I have described today, it's not only a search engine, but we also need to validate the claim. That is, we need to conclude if the claim is probably right or wrong or something in between. And in order to do so, we need to reason over the sets of evidence pieces found with our approach and summarize those to reach a particular conclusion and the result of fact-checking. So as I said, in our lab, there has been a lot of research on various sub-problems of argument mining, and we have constructed many data sets, which are all freely available. You can see an overview in this table, and also the models are freely available and can be downloaded from our GitHub website. So finally, there is a web application that you can test online. www.argumentsearch.com, where you can enter a controversial topic and can retrieve the arguments based on the common crawl corpus and the system which I have described today in this talk. With this, I thank you very much for your attention, and I'm really looking forward to some discussion and questions. Thank you.
Thank you, Iryna. Thank you for this great talk. So I'll now open the floor for questions. Anyone with a question? I see there are 2 questions in the chat, but okay, so we'll follow the order. I'll read the questions in the chat. Mohammed asks about whether the corpora are public.
So this question is very easy. So everything is public, and they can find this on our website. So it should be quite easy.
Very good.
I can hear the echo, by the way, so I don't know why this happens.
Maybe it's myself. Okay, so the next question is from Niels. He's wondering whether the generated arguments are novel, or whether they might also be retrieved 1-1 from the training data rather than being generated, and ask whether you have insights on this.
Yeah, we do have some insights on that. So they are really novel. We have performed some manual checks, and yeah, so that was a question that the reviewers asked in the very beginning. So we checked that, and they are really novel. So they seem to combine the aspects in a novel way related to the overall topic.
Thank you. Now we have people in line. The first one is Rodrigo. Can you take the mic, please?
Hi, can you hear me? Yes.
Yes.
So
yes.
Thanks very much for the talk. It was great. I enjoyed it a lot. I'm very interested in all these topics. I have many questions, but I just tried to make just 2 of them. One very, I think, is quite simple, and the other one, you mentioned something at the end, so perhaps you can elaborate a bit more. The first one is about the performance with the transformer systems. So I saw that the performance improved in the classification, in the argument identification, the first part of the talk, so to speak. That is very close to stance detection. And also in generation, you also had better results using the transformers. But it is surprising that you mentioned the fact that you need a lot of training data for the generation part, at least. Because I know that, it seems that for the classification part, the transformers, one of the advantages of those systems is that you can do this classification task, obtaining good results, with much less training data that it used to be required when using neural networks, recursive neural networks, for example. So, do you have any experience or comments about this? I mean, did you actually needed more data for the generation part than for the detection, or did you have some evaluation maybe about that, about how much data do you need to actually do these tasks?
So I'm not sure that I got the gist of the question. So what I can tell you by all means, so we do not have an experiment where we experimented with different amounts of data and looked at the learning curves. So for this, we don't have the evaluation. We just used all the data that we could get with our approach. But one could perform, of course, such an experiment in future work. Thanks for this suggestion.
Oh, it's okay. I was curious because for stance detection with very small data sets such as MEVAL 2016 and those, it seems that the transformers actually need very little data to actually obtain 70 F1 scores and something like that. Anyway.
All right.
And the second,
that's quite interesting. Yeah, but I'm not sure it's true for the generation task.
Yeah, so that was my question actually. So the second one, very brief also, you mentioned something at the end. Did you have experiments apart from fact-checking about a sort of multi-hop argumentation, that is trying to find if something supports an argument using several evidence or several sentences, so to speak. Because if I understood correctly, most of the data set you generated in the first part is you've got one argument and you've got some topic, and then you just decide whether that argument is actually supporting that topic or not. But did you do that with several claims? Which is something that for fact checking is very important.
So we did not do anything multi-hop, at least in the work which I have presented. I think that the problem of claim validation is a separate problem which I did not cover in the talk. So I've just concluded that it has some structural differences, or it is kind of related but a different task. And the task of claim validation can be formulated as a question answering task, because you can translate any claim as a question. So is this true or not, right?
Yeah.
And if you do this, then you can use all the multi-hop research that we have in the question answering domain. But this has not been done in our work yet. So
okay,
it's a good idea to do that. And and maybe I just want to add, about what we have done instead of like multi-hop. We have done some work on argument clustering. So I did not cover this in my talk, but in our ACL paper, for example, there are some experiments where we cluster the arguments, since this is very important in order to have a good presentation to the user. Very often the same argument will be repeated with various words, and for user it requires a better interface how to present this information by aggregating similar arguments. So this research has been done, and you can refer to the literature from our lab on this point.
Okay, that's interesting. Thanks a lot. Thanks again for the talk. It was great. Cheers.
Thank you, Rodrigo.
Thank you.
So now we can have a question from Paulo. You can take the mic.
Thank you, Eneko. Thanks, Iryna, very much for your talk. Yeah, well, I have a question, or well, actually, I would like to know your opinion, because I have the feeling that when an issue is very much controversial, especially in social media, well, let's think about Twitter. You know, communities are very polarized, so they live in their filter bubble, and they don't really argument much. I mean, I'm saying so on the basis of my very small experience with students who analyze, try to mine arguments in a Twitter corpus about the referendum in Catalonia, in Spanish and in Catalan, and actually it was difficult to come up with to extract some arguments from there. So I have, of course, it will depend on the platform, because I mean, in Twitter, okay, not a lot of space, but probably it's easier to achieve, to extract better arguments in a political debate, or in a channel where at least the text are a little bit longer, and maybe also the issue is not controversial. I'm thinking, I was saying this because potentially would be very much interesting, I think, especially in relation to also what you said in the last part of your talk about the automatic argument generation, to come up with arguments to to have a counter speech to hate speech, so a counter narrative to hate speech. But first of all, I also doubt. So I'm curious to know if you know some attempt, some preliminary works on that. I'm a little bit skeptical with respect that when actually people use a speech, they are not very prone in listening to arguments and to try. Probably it wouldn't be so easy to try to come up. Well, first of all, to generate. Well, maybe this is not so difficult. Automatic arguments on the basis of what you show us, but would be pretty much difficult to try to convince someone with respect to some hate statements. So are you aware about some preliminary attempts? Do you think that could be interesting to give a try? Well, thank you very much.
All right, thanks a lot, Paola. First of all, I'm really pleased to see you in this talk. I somehow did not know you were there, so really nice. And thanks for your very nice, comprehensive comment. I have many things to say about it, actually. So first of all, I'd like to confirm that we do not find many arguments on Twitter or similar social networks. We have already tried that as well and have the finding which is consistent with your finding. So people do not really formulate arguments on social media. It's more about opinions. So for opinions, we can get a lot of data, but for arguments, we don't get much data. However, I can give you maybe one research idea we had, but unfortunately have not found the time to work on yet. So one idea was that one can reframe the classification task to a preference task. So given two statements extracted from Twitter, which one is more argumentative? So I hypothesize, based on some other work that we have had in the lab on different tasks, this task is much easier than the classification task. And based on that, one can learn a function to score each statement as being argumentative to a specific degree, right, on the scale from 0 to 1. I think this can be done, and we would love to do that when given the opportunity and the resources. So this is one idea. And then the second part of the question was about the hate speech and generating counter arguments. So in the beginning of my talk, I've pointed out that argumentation is a very, very interdisciplinary topic, right? So it's a very old topic, starting in philosophy thousands of years ago, and it's a big topic in psychology, among other fields. So what we do in natural language processing is very often sort of on just one dimension. So we have text, but argumentation has also rhetoric. It also has other dimensions related to convincing people. It's not just the rational content, but it's also how we frame that content. And I think that like formulating counter arguments to hate speech, something can be done, but the approach would be different to what we present, because what we present is the rational level. But hate speech goes beyond that. It's very much related to evoking people's emotions and referring to specific values. I think that task is much more complex, and I don't know any work that is trying to do that, but I think it would be a great idea to work on this kind of research. So yeah, I hope that's kind of good answer to your question.
Thank you, Iryna, very much, and thanks to Eneko and German to organize such interesting webinars for everybody. That's why we are around.
Thank you, Paolo.
Very nice.
So, Iryna, I wonder, it's already 4, there's still 4 questions in line. Are you okay with continuing?
I'm okay, so I don't have any subsequent meeting.
Okay, so we can stay for a few more minutes. So next one in line is Carlo. Then we have Horacio, and then, last time I looked, we had 2 questions in the chat. Yeah, we have 2 questions in the chat. So, Carlo, when you want, take the mic.
Thank you. Can you hear me? Can you hear me? Perfect. Nice. Thank you for the fascinating presentation. I have a comprehension question. I come from a slightly different disciplinary area, that of abstract argumentation. In abstract argumentation, yeah, I mean, argumentation is basically studied as graphs of interacting arguments. And from this point of view, we study acceptability of arguments based on structural properties of the graph. And so my feeling, but correct me if I'm wrong, is that, okay, first, there are then different ways of being, for an argument, of being pro or con another argument. So I can support the topic or the stance directly, or I can be a defender, okay, attacking an attacker, meaning restating an argument. My feeling is that after this presentation, that your annotation schemes generate what so-called bipolar graphs of depth 1, meaning you only have directly pro and directly contra arguments, but correct me if I'm wrong. Well, since the theoretical interest in my community is to study argumentation as complex graph, I wanted first to ask you if I'm right, if I understand it right, or and if there's work in the NLP community or in your research group towards this direction, and if you think this is an interesting dimension for analysis. Thank you.
Yeah, I think it's very interesting. Thanks for the question. Maybe something to switch off because I'm hearing my own voice. Yeah, I get this question quite frequently. I mean, argumentation is also a huge field in artificial intelligence, and there's a community of people working on argumentation graph, the whole comma community. And what you have understood from the talk is completely right. So our approach is quite flat, so to speak. So it's very simplified as compared to the structures which are studied in that other community. So in the very beginning, we have experimented with annotating the data regarding more complex schemes to construct such argumentative graphs. However, we unfortunately failed to achieve acceptable levels of annotation agreement. And also it's very hard, so we did not manage to scale this up with the crowdsourcing. It was very difficult even with our quite simple scheme. The reason for that is that humans are not a good model for argumentation. Argumentation is quite a difficult skill, you know, so we need to study this in school and also at the universities. And even if you read scientific papers, very often the argumentation is very vague, you know, even for researchers. And we failed in many experiments where we tried to annotate this in the data. And unfortunately, in NLP, we depend on the availability of a large-scale data in order to train our classifiers. So one work we have done with a more complex annotation scheme is based on toolmeans framework. So we managed to annotate data with that framework. It's much richer. But we did not manage to crowdsource that. And whenever you work with expert annotators, it's very slow and it's very expensive. And I think this is the reason why there is not much work in NLP. So no work really I know that can construct such argumentative graphs at large scale. So this is a big issue with creating the training data. And the second issue is that the NLP is not so good at semantic parsing. So semantic parsing is one enabling technology to construct richer graphs, but it fails on real life. And so in order to construct such graphs, you would need to solve this problem of semantic parsing on heterogeneous large-scale data first, and this is a hard topic in itself. So far, we still need to work to achieve some progress there, and I would be really looking forward when these communities of working on argumentation in NLP and the common community start collaborating more on this.
Thank you, Iryna. Next in line is Horacio.
Thank you.
Welcome.
Yes. Thank you, Iryna, for the great talk. I am a little bit concerned about the part of generating arguments because I want to know your opinion. I mean, generating, for example, other types of text, factual text, let's say, summaries, etc. So you can, let's say, verify the truthfulness of the statements. But in argumentation, this is quite different because it's quite subjective. So I wonder how you measure the success of a system that is generating, because, I mean, obviously in presidential debates, I mean, who won the debate can give you some idea of how successful the arguments were. But how you do it in this context, in the context of computer generating just one argument, or I mean a sequence of arguments in a given topic. So it will not
that's
be
a great question.
Comparing with the truth with a gold standard. I mean, a gold standard can be meaningless here to compare. Because
evaluating
you can generate different arguments, I mean, on different dimensions. So I wonder what is the successful of the system here. Thank you.
Yeah, I think, I mean, this is a great question, and I completely agree that the evaluation is a very hard topic. I mean, it's true for the field of NLP in general, and it's true for the whole NLG, and the problem of generating fake arguments that are false arguments. So that exists. So I don't have really like a good answer to that. I'm afraid the community does not have such an answer yet. What we have done, there exists research on argument quality assessment. And there is a corpus from IBM. So this is the group of Noam Slonim, whom I mentioned several times. So they annotated arguments and trained a model that can measure the quality of arguments. So what we did is I unfortunately did not include a slide on that evaluation, but I do have it, and it's described in the paper. So we applied this argument quality assessment to the corpus of automatically generated arguments and to human generated arguments, and we achieved similar scores. But by looking at the output of the argument generation, we feel like the arguments are of good quality. But of course, false facts could be included, so there is no verification. So then you need something like claim validation, or basically fact checking, fake news detection, in order to spot false things being generated. And then, of course, what you can do, and we already, and we also did that. So we just evaluated, we collected some human judgments on the fluency and syntactic correctness and things like that. So these are the approaches we have used, but I don't have the global solution to this, since I think it's a higher level problem how to evaluate neural NLG in general. So does it answer your question?
Well, I think it's a great topic to investigate and to make advances. Thank you very much.
Yes. Yeah, I completely agree. That's a great point.
Okay, thank you for the seminar. Thank you. Bye.
You're welcome.
Thank you, Horacio. So now we have 2 questions in the chat. I'm not sure people is still there. Konstantin asked whether there are ambiguous arguments that could be seen either as pro or con, depending on your perspective, and if so, how would that affect the model?
Well, ambiguity, of course, applies to any problem, and also in case of arguments, we don't have a perfect agreement right? So we collect training data, and then we run this maze metric, which conflates human judgments to a single gold standard, taking the competence of the workers into account. So in the training data, there is no ambiguity because we train with a gold standard or ground truth. But in general, such cases happen in the data, of course. But I mean, it's true for any NLP task. And also, nobody has asked that question, but the question is quite obvious. So one sentence can contain multiple arguments, or a single argument can be spread across multiple sentences. So this situation, of course, happens. Our approach is agnostic of this. And from our unpublished experiments, I know that depends a lot on the text type. So if you, for example, analyze newspaper text, then you will have many cases where a sentence is long and complex and it can contain several arguments. In such an approach, in such a setting, our approach cannot perform well. But we have some other work together with a group of Hinrich Schütze at the University of Munich, where we formulate argument classification as a sequence labeling problem. So this way we can also classify parts of sentence as being an argument unit. So there are different variations of this approach.
Okay, and finally we have a question from Shore. Could you please explain how the concept of framing in political domain can relate to argument aspects? Not sure I understand the question.
Well, that's also an excellent question, but it's a very hard one. So I actually don't know, right, like from my head, of any work that studies the relation between framing and argumentation. So it's an empirically open question, in my opinion. So we have some work on framing in initial stages, but I think that would require that somebody constructs a corpus which contains these two levels of pragmatic analysis. So then that question could be answered. But I'm afraid I could only speculate about this. I really don't know. I think this is interrelated, but the exact relation needs to be studied.
Thank you. So I think, thank you, Iryna. This was a great talk on a fascinating topic. I have to say that, well, I had also some comments, but it's late. Well, one brief comment is that I had a physics, at high school, I had a physics teacher who was fond on some Russian school of teaching physics, which was based on argumentation, argumentative dialogue. So actually, I have my notes somewhere where she was teaching concepts about physics using this kind of argumentation between a student and a lecturer, I think in the Aristotelian style. So I think this is really fascinating with lots of ramifications. And something I really liked from maybe a more generic researcher perspective is that in this data set, the gap between the machines and the humans is still large. And I think that in NLP, we need to define in general, I mean, it's not only for argumentation, but for other topics as well. We need to have problems where the machines applying just pre-trained language models are not performing as well as humans, because that's where I think our knowledge about the field might shine. So I really find this.
Yeah, I completely agree. This is a very fascinating topic, and this is a vast topic. It's very big because argumentation is related to reasoning, and reasoning is part of any analytical field, you know, or part of life. So, for example, we had some cooperation with a medical school. So they need to reason to derive the right diagnosis for a patient, right? And they have very interesting questions, because in medicine, for example, it's important not to do too many investigations. So how can you reach the right conclusion given the minimal set of evidence? So there are variations of these questions. And yeah, I agree. This is very fascinating. And it's very, very broad. So with huge applications in various areas of life.
Okay, so thank you again. And thank you also for being here after the time. So I'll give you a round of applause.
I was really, yeah.
Yeah.
It's hard to do interactively in this setting, but I was really pleased to have this discussion. It was great. Great questions.
Thank you very much.